Exercise number 12. Write an inequality whose solution set is the sketched region. Okay, this region, it's a half plane. So, observe, the region is a half plane. And once we have a half plane, we know what can work here. Can use a linear inequality. The graph of a linear inequality is always a half plane, which is just what we have here. Alright, well then we're going to first need the boundary line. The boundary line equation. Where to begin? Let's see, what do we know about this line? Well, we see its y-intercept. We also have its x-intercept. Well, there's a couple of convenient starting points here. Okay, perhaps one starting point might be to consider slope-intercept form. Y equals mx plus b. That's slope intercept form. Alright, let's try to obtain m. M is the slope. In terms of this graph, we can think of slope as being rise over run. As we move along the graph left to right, we have these two very clear points here we can use for the basis of rise to run. As we go from here to here, the rise is 1, the run is 1, 2, 3, 4. Okay, 1 to 4. 1/4 is the slope, that's m. What about b there? B is the y-intercept. That's why this is called slope-intercept form, and that is a 1. Okay, let's put this all together. Y equals to 1/4 x plus 1 is our boundary line. Now, since we have this boundary line in the form of a y solved for, y equals to some f of x, we can think in terms of, do we want above or below the line? Here we want below the line, and this means we want our y to be less than or equal to, because the boundary line is solid, finally giving us y less than or equal to 1/4 x plus 1. Okay, just to be extra sure, we could try to check here. I like to work with 0, 0 because the arithmetic is just so easy. And in this case, 0, 0 is in the region. And this means that upon substitution, must make the inequality true. Alright, here goes our substitution. 0 for y. There's the less than or equal to sign. 1/4 times 0 plus 1 simplifies to 0 on the left-hand side. A 1 on the right-hand side. Is 0 less than or equal to 1? True. That's what we wanted to see. Okay, this looks good. Exercise 14. Write an inequality whose solution set is the sketched region. Okay, this sketched region here, it's a half plane. So observe the region is a half plane. Alright, if we see this, this implies that a linear inequality will do. Okay. Okay, well, we're going to need the boundary line equation. Let's see, what do we know about this line in terms of good information? Okay, a good x-intercept, a clear y-intercept. Alright, a couple of directions you could go here. You could work off of either intercept form or slope intercept form. I suppose slope intercept form is actually kind of nice here. So let's think about that. That's y equals to mx plus b. Again, that's slope intercept form. Alright, now what do we need to complete this form? Need the slope, m. What could we do? Well, one thing we know about slope is it's rise over run as you move along a line left to right. Let's go from this specific point to this specific point. The rise is, well, down, that's a -2. The run is 5 units. Okay, so rise over run is -2 over 5 in this case. That would give us our m. And b, that's the y-intercept. It's a -2 in this case. Okay, we're ready to put together the boundary line equation then. Y equals to -2/5 x minus 2. Now with this boundary line equation like this, y is solved for, y is equal to some f of x. We can think in terms of, do we want to be above or below the line for our region? The region lies below the line. So this has us thinking in terms of y less than the -2/5 x minus 2. Now the boundary line is dashed, so we have to make sure that we don't have the boundary line becoming solutions to our inequality. So our inequality should just be less than. Don't put an equal sign into it. So this gives us y less than -2/5 x minus 2. Put a prominent cloud around this conclusion here. Let's try checking things out here a little bit before we walk away from this. 0, 0 is always really easy to work with for arithmetic. And in this case, 0, 0 is not in the region. Okay, so 0, 0 is not in the region. Okay, since it's not in the region, then upon substitution, it should make the inequality false. Alright, here goes our substitution then. 0 for y less than -2/5 times 0 for x minus 2. This simplifies to 0 less than, that's just 0, minus 2 is there. Is 0 less than -2? No, think of the number line. -2 is less than 0, in fact. So this is false. But that's just what we wanted to see, since 0, 0 is not in the region and not a solution. Okay, looks good. Exercise 16. Write an inequality whose solution set is the sketched region. Okay, this sketched region here, it's a half plane. So observe, the region is a half plane. And the implication there is then a linear inequality will do. Okay, we need the boundary line equation then. Okay, let's see. What kind of information have we got? for this line, we have these 2 points that are, each of them is in the middle of a quadrant somewhere. Okay, in this case, perhaps point slope form might be good to work with here. So y minus y1 equals m times x minus x1. That's point slope form. Forms of equations are just things you have to just memorize in math. It just does kind of come to that. Alright, in this case here, now let's try to fill in the parameters of our form. For instance, m. How can we get that? In this case, we can remember that m, slope, is equal to a y sub 2 minus y sub 1 over x sub 2 over x sub 1. If you happen to know 2 points, and we do. Alright, for the purposes of this calculation, consider the right point, the y2, and the left one, the y1. So now we would have a negative 2 minus 2 over 3 minus negative 5. Alright, minus negative 5 is known as plus 5. So this becomes negative 4 over 8, more simply known as negative 1/2. Does that make sense with what we see here, roughly speaking, graphically? Yes, it does, because this line is going downhill as you travel left to right. That's a negative sloping line. And as another benchmark, the perfectly diagonal line downwards like this with an angle of 45 degrees off this axis here would have a slope of negative 1, and this line is clearly not as steep as that one, so its slope should not be as negative as negative 1. It's not. So everything is looking good up to this point. Alright, now for our putting in our x1, y1, we could use either point. Let's maybe just arbitrarily select to use this one as the x1, y1 now. And this means we could have a y minus a negative 2, okay, y plus 2, we'll just call that, equaling to negative 1/2 x minus 3. Alright, and perhaps it'll be convenient for us to have the y solved for here, so then we can get our inequality by thinking in terms of above the line or below the line kind of thinking. So let's solve this for y. Then I'll expand this a little further then, and this is a negative 1/2 x, and then plus 3/2. Now we could subtract 2 from both sides. There's 3/2, subtract 2, that's negative 1/2. Also, we can kind of check up on ourselves right now, because now we have this in slope-intercept form. And this means that we're claiming that negative 1/2 is the y-intercept. Does that at least look graphically consistent? There's 0, there's negative 1. Yeah, negative 1/2. This is looking pretty nice. Okay, so the boundary equation looks pretty good. Now, to answer this question, though, we need to get this region to be the solution set. We think in terms of wanting below the line. So we're thinking in terms of a y less than the negative 1/2 minus negative 1/2 x minus 1/2. And then we also notice the dashed line here. So we do not want to put an equality in this inequality. We need to leave that out. We want to have strictly y less than negative 1/2 x minus 1/2. Okay, now as a check on this conclusion here, let's see, I like to work with 0, 0. Now in this case, 0, 0 is not in the region. Okay, so upon substitution, thus, upon substitution, should yield a false statement. Alright, let's substitute in 0, 0 to our claimed inequality and see what happens. 0 for y less than negative 1/2 times 0, negative 1/2, subtract 1/2. This simplifies to 0 less than 0 minus 1/2. 0 less than negative 1/2? No, think of the number line. Negative 1/2 is less than 0, of course, though this is false. But that's just what we wanted to see. That's our check. So this looks pretty good. Exercise 18. Write an inequality whose solution set is the sketched region. Okay, this sketched region, it's a half plane. So observe, the region is a half plane. Alright, when you have a half plane, you know that you can describe it with a linear inequality. So this implies that you can use a linear inequality. Alright, how about the boundary line? The boundary line equation. Look at this boundary line. It's a vertical line. Okay, so what comes to mind is we're basically looking at x equals to a constant type of an equation. This is called vertical form. Specifically here, we need our x to equal 1 to negative 3. Alright, so there would be our boundary line. Now in this case, we want to be having all the points to the left of that line. That's less than, having x to be less than the negative 3. So x less than, and what about the or equals to? It's a dashed line. So we do not want to have the equality be part of our inequality. Strictly x less than negative 3 is all we want. Okay, this is it. Very simple check. 0, 0 is not in the region. And this implies that upon substitution, should make a false statement. Okay, let's see what happens. X is here, it says 0 less than negative 3. What about this? False. Okay, but that's what we wanted to have happen, because 0, 0 is not in our region. Doesn't belong in our solution set. Okay, this looks good. Exercise number 20. Write an inequality whose solution set is the sketched region. Alright, this sketched region, it's a half plane. And we are provided with this equation for the boundary line. Alright, so let's notice that. Boundary line equation. That's the 7x minus 3y equals 21. We also notice this boundary line is dashed. So the final answer is not going to be an or equals to type of inequality. it's strictly going to be greater than or less than. But now we need to figure out whether to write an inequality with a less than or a greater than sign. Okay, so we need to determine the type of inequality. What to do? Well, we could do this. We could say 0, 0 is a solution, which means upon substitution, 0, 0 should yield a true statement. So upon substitution, zero, 0 must yield a true statement. Again, because it's in the shaded region, it's a solution. If it's a solution, by definition, this is what has to happen. It must yield a true statement. Okay, well, let's put 0, 0 into our future inequality here. We'd have 7 times 0 minus 3 times 0 on the left. We have 21 on the right-hand side. This is simplifies to 0. Here's 21. Now, we need this to be true. 0 on one side, 21 on the other side. Okay, well, 0 is less than 21. That's what we require then. A less than sign to make that be true. So this finally gives us 7x minus 3y less than 21. A final answer. Now, let's not be too hasty. Let's check over our work. Okay, for a check, let's see. Let's take a point that's in the solution set here. How about 1, 1? 1, 1 is a solution. It's in the shaded region. Okay, so upon substitution, what would we have? 7 times 1 minus 3 times 1 less than 21. Here's 7 minus 3, that's 4, less than 21. This is true. And that's just what we wanted to have happen since it was a solution. Okay, so this looks pretty good. A final little extra here. In case you were thinking about rushing and putting a greater than sign in the inequality because you see that the region lies above the line, you need to be careful there. That kind of strategy works when you have y solved for, or y alone on one side of your boundary line equation. That way you can talk about y greater than 3x plus 2 or y less than 6x minus 9, these sort of situations, if y is isolated. In this boundary line equation, there's no isolated y, so we had to be a little more careful. But yet, it's a very fast method which you can use to determine the inequality, doing it this way. Okay, good.